Hi, this is Roger from Kanka Labs, and today it's about pocket calculators every maker should have one of. I've brought here from my home and what we use here in the lab the HP-15C, the HP-35S and the Casio FX-61F, and each one of them is, especially these two, are quite famous in scientific and engineering work because they are quite unique. Each stands out with features that no other calculator does have. And so let's take a closer look at each one of them and start with the HP-15C. So before we go into some of the special functionalities and the special features of the HP-15C, let me tell you a story about how and when I got this one. Hewlett-Packard was famous, of course, in Germany for every science nerd, even from the young ages. But when they came out with their first calculators or scientific calculators, the price in Germany was equivalent to the month salary of an engineer, so nothing you could afford as a normal hobbyist or school pupil. And when I started my university time in around 1982, this series here, the HP-10 or 1X series, the famous Voyager series of pocket calculators, came out. This was the top model. And in Germany it cost at that time 300 Deutschmarks. I think I still have the original invoice for that one. And it's still quite substantial money for that time. It translates to about 400 euros of today's currency. And now the special features of these are, first of all, the LCD display is the best readable I've ever seen. Nothing has ever beaten the contrast and the readability of this LCD. And I think they even produced an anti-reflection coating somehow on the top glass, because although here I can of course produce some reflection, but in real life you can see through it as it would be non-existent. So this is the display is extremely clear. And the Voyager series is also known for having ultra low current consumption. So I got this around 35 years ago, and I've changed the batteries once or twice, not more. So the battery life is determined basically by the self-discharge of the battery. There are 3 LR44 batteries inside. And how did they reach this? Well, they produced a chip not on silicon, but it is silicon on sapphire. So this is a semiconductor production technique rarely used today, only perhaps for space applications, because silicon on sapphire is more robust against space radiation. And so the battery life is absolutely incredible. Next, what HP calculators are famous for, they have the best keys ever of any calculator you will ever encounter. Nothing beats the keypad of HP calculators. I never ever had a key bounce or something like that. So you can use this nearly blind because you never get any unwanted key pushes or something like that. And what HP also is famous for is the lettering here. This never wears off because it's in a special double injection molding process built. So it's really, HP did from the first time on when they produced scientific calculators, they really did all the best. Even the distance between the single keys, they were all tested out by engineers. And so this thing, of course, what you first will notice is the strange aspect ratio, that it is in landscape mode and not, as you usually know, in portrait mode. But this is really, you can use it with one hand, and I will never give this one away. What else it was famous for, you could use it with complex numbers, and you could calculate with complex numbers just as with normal numbers. And it had matrix function, and of course it was programmable. But for everyday life in my home lab, where I have this one stored, of course I'm only using the normal scientific functions, and I don't use the programming functionality anymore. I've used that during my university time, but today I'm using it just as the scientific pocket calculator with the absolute best usability. So if you try to get one of these from eBay, don't be surprised. They cost today more than the retail price when they came out in the early to mid 80s. So I have a tip for you. Don't don't search for the HP-15C. Search for the HP-11C. The 11C has the same functionality concerning the scientific functions. It only lacks of some of the programming features. Get an HP-11C, and you won't find much users who will ever give their HP-15C away. And be aware of, due to the great demand, HP later they reproduced, they made a special edition, but they did not use the original silicon on sapphire chip. They just reprogrammed an FPGA with the processor that is used here. And of course then you don't have the 10 or 15 year battery lifetime anymore, because the FPGA draws a lot of current. So it's better getting the HP-11C, an original one. And of course from the Voyager series, what's also famous is the HP-12C for business applications, which is produced until now. So for more than 30 years, probably the pocket calculator with the longest production time is the HP-12C, but that is not usable for us engineers or scientific nerds or hobbyists, etc. So, but of course this was more intended for programming and for the matrix operations, etc. If you want to get a newer HP calculator, I'd recommend the HP-35S, which we take a look now. So you can immediately see from the HP-35S that the technology of even of HP calculators has advanced a little bit in the last decades. Now you have a two-line display with much more decimal places. Here the HP-15C only had 10 decimal places, and here you have a lot of more. And furthermore, this is a dot matrix display. Although the fonts they use, they are also very readable. The readability of the LCD is also very good, but if I would give the HP-15C 100%, I would give this one 85 or 90%. So it's nearly as good, but it does not have the anti-reflection feature. You can see you get much more reflection here than with the, also it's not as visible here as in real life, but believe me, the HP-15C gives really in real life no discernible reflections. So of course this one is also programmable. It also can display alphanumeric characters, etc. But we'll discuss just the basic scientific functions that are useful for everyday life. So although HP calculators are famous for their RPN, the reversed Polish notation mode, which, if you ever understand the advantages of RPN, you will never ever want to go back to algebraic mode, but the HP-35S can be switched between algebraic and RPN mode. So if you want to, you can use it as the normal, all the other calculators. But of course I would recommend using RPN because it's much better for scientific calculations. You don't need any brackets in calculations. I think it's the much better way to use a scientific calculator. And the other mode settings are of course degrees, radians or grads. What is that in English? I don't know. Anyway, so let's go to RPN mode. This is also displayed here with a little RPN symbol in the top of the display. So the next things you can set are the different display modes. And of course you have the choice between fixed format, scientific format, engineering format, and show all numbers or the whole mantissa. And what do we have as a decimal separator? Either the American version with a dot or the European or German version with a comma. And if you want to have thousands separators, and what's quite interesting, how you display complex numbers, either as xi for the imaginary part y, or in polar coordinates. So that's quite nice. Of course we do not use any thousands separators, and of course we are using the engineering display. So we have some nice inbuilt function just for unit conversions, degrees Celsius, kilogram to pounds, and degrees Celsius to degrees Fahrenheit. Of course the usual HMS from hours, minutes, seconds to decimal, and the reverse, radian to degrees, that's standard. Miles to kilometers, inches to centimeters, gallons to liters. That's what we here in Europe, when we read American journals or articles, quite often have to do. So another nice feature is that you have all the usual physics constant already stored. If you go to constant, you can see some little symbols like for the speed of light, the standard acceleration of gravity, the Newtonian constant of gravitation. Let's see what we have. Of course the Avogadro constant, Rydberg constant. What you sometimes need is the charge of an electron, or the elementary charge, the electron mass. What else do we have that we sometimes use? The Boltzmann constant K, that is sometimes used in electronics calculations. Planck's constant, etc. The Faraday constant we have somewhere here behind. Here it is. And well, everything you need, and you can quickly, or here the μ0, the magnetic permeability of vacuum. That's also quite often used in calculation with magnetics or with induction. So quite also a nice feature. So except for working with normal numbers, with complex numbers, with vectors, you can also use a fractional mode, so that fractional numbers are displayed and you can calculate them. I've never used this functionality, but what's more interesting is you can do calculations and conversions between different bases, which means the normal is of course decimal mode, but you can also input or convert a number to hexadecimal, octal or binary display. So let's for example convert a decimal number to a hex number. Let's input 1, 2, 3, 4 and convert it to hex, and we get 4D2 in hexadecimal. The lowercase h here means that it's displayed in hexadecimal units. So really a nice feature when you do a lot of programming stuff, and you can also not only convert the numbers, you can really use the normal arithmetic functions. So for directly, for example, multiplying two numbers in hexadecimal display. And not only that, you also can do the normal logic functions like XOR, or not, NAND, NOR, AND, etc. So also quite nice when you do a lot of work with microcontrollers, etc. So, and of course you have all the statistic functionality, but I think the inbuilt functions, they are quite unique and quite helpful in engineering and programming applications. And of course it has the famous yellow, blue second and third functionality, and not all modern HP calculators in fact do have the super good keys that HP is famous for. There are also cheaper versions. So I would recommend, if you want a new, still available HP scientific calculator, get the HP-35S. It's not a $10 calculator, so you have to spend a little bit more, but HP is HP, and it's really usable for works for applications in the electronics lab and in programming, etc. But now finally, let's take a closer look at the holy grail of engineering calculators, especially when it comes to electronics, the Casio FX-61F. So let's first of all take a quick overview of what you get when you get one of these from eBay. It comes in a I think artificial leather, or how is it called, or plastic case. It's dual powered with solar cells and an internal battery, which only can be changed after taking off some screws. And if you're lucky, you get the original manual. Here it's in English and Espanol, so not English and German, but seems to have been a special edition. Anyway, if you don't get the original manual, you can download it for free from the internet. And the first nice feature for engineers, here you can see that the different modes you can set in, they are not only the standard fixed decimal places and the scientific display, but also a base N. That means you can also do, just as with the HP-35S, you can do conversions between decimal and hexadecimal, and you can also do calculations in hexadecimal. So quite nice. And this is an important mode, the impedance mode, which we'll come to later. And of course, and standard deviation, so you can also do statistical calculations, which I rarely or never use. The first nice feature is when you want to input the standard prefixes milli, kilo, mega, micro, nano, pico, you just do this by, let's say, if you want to input 45 pico, whatever, farad, so it gives you the right exponent. That's already quite nice. And now, when you press enter or the equal key, then first of all it is converted into standard scientific mode. But when you want to get the standard engineering display, you simply press here the engineering key, and if you press it repeatedly, it changes through the different designation. Here we are at femto and then atto, etc. So that's really designed for the engineer, just to being able to input the standard prefixes and then with the engineering key going through all the different engineering exponents. But you can already see here are some symbols that shows that this calculator is designed for electrical engineers or electrical calculations. So let's start with the first nice feature, and that is this little key here, where you simply can calculate the resistance of two parallel resistors. So let's suppose we want to calculate two parallel resistors, one of 45K, and then we press the parallel button and 56 kilo ohms, and we press equal and we get 2.495 etc. times 10 to the 4th power. We press engineering display and we get 24.95 kilo ohms. So this is not only done with real resistors but also with complex resistances. So we'll come to that just in a minute. So when we do impedance calculations, we of course have first of all to specify the frequency that we're working at. Let's say we want to do calculations at 1 megahertz. So we input 1 megahertz and push the F in, frequency in. We can also recall the entered frequency. If we press Shift F in, then we get the frequency out. You can directly also see the omega frequency by which is the multiplications with the 2 pi, by pressing Shift Omega. So now we want to know, for example, the impedance of an inductor of, let's say, 10 nanohenry, and we just input 10 nano and press the symbol here for the coil for an inductor, and we immediately get the impedance at our selected frequency of 1 megahertz, which is 62.83 milliohms. And you can see the little J symbol that we're now having a complex number. If we want to know the complex, the imaginary part, we would have to press here the real to imaginary exchange button. But of course, for a pure inductor, the imaginary part is 0. The same for a capacitor, let's say a 10 picofarad capacitor at our selected frequency of 1 megahertz, and we press the little capacitor symbol, and we get now, of course, minus, because capacitors have a negative value of impedance of -1, or in engineering mode, of minus 15 kilo ohms. So that is the simplest way to use complex calculations or calculations with impedances. Now, of course, you can do calculations to add two different impedances, and I'll give you an example in a second. Now let's suppose you want to calculate the impedance of a resistor in series with a capacitor, let's say, well, 40 nanofarad and 5 ohms at 1 megahertz. Let's check if our 1 megahertz is still in memory as the frequency. Yes, it is. So we input 40 nanofarad with the capacitor symbol plus 5 ohms, because an ohmic resistor only has a real part. We only have to input the 5 without any further symbol. As a result, first of all, we get the real part, which is of course still 5 ohms. And now we want to calculate the impedance of this series combinations, and we press the Z button, and we get Z equals 6.39 ohms. So that is quite easy. You can also do parallel combinations or combinations of series and parallel and any sorts of calculations with complex electrical components. So that is very nice. You also can, of course, calculate the angle of deviation, etc. You can put the complex numbers into memory, and you can use the brackets, etc. for still more complex calculations with complex numbers. So that are really unique features. Already here the calculations of parallel resistors or parallel impedances, already that would give this calculator an outstanding feature in calculator history. And as you can see here, you also get this little cutout here to store in the plastic case with inbuilt formulas. Like, I will read out some of them: frequency of electric oscillations, change in the terminal voltage of an RC series circuit, the time constant for an RC series circuit, the conversions between star and delta configurations, resistance of matched impedances, power factor, closed loop gain of op amps, inverting feedback circuit, filter circuits, voltage gain in decibels, power gain, resistance of a conductor, and what else do we have? A plate capacitor, Coulomb's law, Joule's law, which I always call Ohm's law of power. The power equals resistance times the current squared, or voltage squared divided by resistance. Stored energy in a capacitor, stored energy in an inductor, and what else? Lorentz force, electromotive force. So quite nice. And let's do just one example with, for example, what do we take? I also got this in Spanish. What do we quite often use? Let's use formula number 1, the frequency of electric oscillations, or as it's known in Germany, Thomson's formula of oscillation. So because this is formula 1, we're starting with inputting 1 and then formula, and then it already asks with an alphanumeric symbol for the inductance in our parallel tank circuit or series resonant tank circuit. And let's say we take 170 microhenry, run. We don't have to use the equal sign, but run. Then it asks for the capacitance, and let's say we take 500 picofarad. Again, run, and then it calculates the resonant frequency in engineering mode, 545.9 kilohertz. So that's how easy you can use the inbuilt 27 formulas. But if you want to, you also can program your own formulas for, like, for example, when you have special combinations of impedances that you don't always have to use the plus and times X button, etc. But just enter the values just as you saw here in the formula number 1 for the frequency of oscillation. And so this is an absolutely unique calculator. Every maker should have at least one of these. They are quite hard to get on eBay. I've all in all 2 of them. This one here with the original case and with the original manual, and a second one. But I saw in the last 3 years, I think I saw only 3 or 4 times that you could get them on eBay, and twice I was lucky for not very much money. I think both cost me less than 50 euros. But if there's an offer with a buy now button, you probably will pay more than 100 euros or dollars. But every maker should have one of these. And in addition, perhaps the more modern the more modern HP-35S, and for your collection perhaps an HP-15C or 11C. So that was it for today for the best calculators for electronics nerds. And thanks for watching. If you liked it, please give it a big thumbs up. Until next time, bye from Roger, bye from Kanka Labs.